And you'll notice that we have some kind of like nice points here in our graph. Okay, which hopefully should make sense. Because remember, so for example, again, our equation, our function here is log base 2 of x. Okay, and when you go to pick values here, if you want to do this mental math without having to use a calculator, you're going to want to pick x values that are, actually I'll do f of x I guess here instead of y. What kind of x values do we want to pick here to plug in that we can evaluate easily? What things can we easily do the log base 2 of? Okay, so, right, we want powers of 2 specifically, powers of 2. So an even number like 2 would work, 4 would work, 6 would not work, because 6 is not a power of 2, but 8 would work because it's a power of 2. And so if we pick like, 2, 4, 8, 16, we can easily then evaluate that. Log base 2 of 2, remember that's like asking 2 to what power gives us 2. So what would that be? 2 to what power gives us the number 2? 1, right? Yeah. Or log base 2 of 4. Log base 2 of 4. 2 to what power gives us 4? 2, right. Okay. And then log base 2 of 8, 3, because 2 to the third is 8. Log base 2 of 16 is going to be 4. But you'll notice here they also have some like fractions, right? Because we could also do stuff like, and I'll make another little table right here just because I can. For example, we can use the fraction 1/2. Log base 2 of 1/2 is going to be what? -1, because it's like 1 over 2. The 2 goes in the denominator. We could also then do like 1/4 if we wanted to. What's log base 2 of 1/4? -2, because it's 1 over 2 squared, or 1 over 4, so -2. And if we look over here, we can see those points kind of graphed. Okay, there's 0.5, which is 1/2. That's log base 2 of 0.5 is -1. And then there's our 1. Oh, we didn't do 1. I missed 1. That was an easy one. Log base 2 of 1, or 2 to what power gives us 1? It's 2 to the 0. So 1, 0 is an easy one to get. Okay, and there's 2, 1, there's 4, 2, and then there's 8, 3. And of course, you can keep going. 16, 4, though, is going to be off the, you eventually kind of run out of points to plot there. It's just too much. And so you end up with this kind of graph. Okay. Right. What does it look like the domain of this graph will be? Is it going to be all real numbers? So from what to positive infinity? 0. From 0. Do we include the 0? Do we actually get to an x value of 0 here? Looks like no. So so if we don't actually get to an x value of 0, what kind of thing is right here? A vertical asymptote at x equals 0. So we have a vertical asymptote here. Our domain is going to be from 0 to infinity. What about our range? What's our range going to be? All real numbers. Yeah, negative infinity, and it's going to keep increasing that way too. So yep, it'll be all real numbers there. Good. Okay. Now let's do the same thing here. We'll do the same thing for the function log of x. We know when we see log of x that is log base what? 10. So I can put a little 10 in there if I want, just to remind myself. Okay, so let's do this. 0.1, what is the log of 0.1? Right, log of 0.1, remember 0.1 is 1/10. So that's equal to then just -1. Okay, so it's 0.1, -1. What about what's the log of 1? Or in other words, 10 to what power gives us 1? 0. Excuse me. And then 10 to what power gives us 10? 1. So we just 1. So it's -1, 0, 1 there. So we'll plot those 3 points. Okay, so it's going to be 0.1, -1. Now, it's, obviously here, there's 1. So we want to go 0.1 in the x direction. So that's going to be like almost 0, and then we're like right there at -1. So it's like just barely to the right of the y-axis there and down 1. 1, 0, that's an easy one to graph. And then 10, 1, so then 10, 1 is way out here, and then right here there's 10, 1. Okay, so you can see that we have a much sharper turn here. This as compared to this one, which is a more gradual turn. All right, here much sharper. We have to go from this point to this point, and then down to that point and on down, right? Because we have that inner asymptote, at 0. So it's gonna be like a really quick turn, and it'll keep going like that. Okay, so there's the graph there. That's log of x, or log base 10. So there's log base 10. There's log base 2. So 2 is less sharp of a turn than log base 10. The next one we want to do is natural log. Okay, now natural log is log base what? E. So we can think about this as being log base E of x. Now, that number E, do you guys remember what that is approximately? It's 2 point something. It's 2 point something. So since E is about 2 point something, the graph here we would expect to be not quite as sharp of a turn as this one, because that's log base 10, but a little bit sharper than this one, because this is just log base 2. Since this is a little bit more than 2, our turn here down here is going to be a little bit sharper than this one, but not as sharp as this one, because that's 10. So let's see. Okay. So natural log of 1 over e, in other words, e to what power gives us 1 over e? Negative 1. Natural log of 1, well again, e to what power gives us 1? It's an easy one, right? E to the 0 gives us 1. How about natural log of e? That's 1, right? E to the power of 1 gives us e. And then how about natural log of e squared? It's going to be 2, right? It's got to be 2. So those are pretty easy to graph. But now we have to go kind of approximate, right? Because 1 over e is a decimal, so we're at about 0.368. Sorry, there we go, fit on the screen. 0.368. So let's see, here's 0.5, so a little bit less than that, 0.3, and then negative 1, like right there. And then 1, 0. It's an easy one. E is about 2.72, and that's at a y coordinate 1, so about 2. And here's like 2.5, so 2.7 might be something like that. And then up 1, so like right there. And then e squared is 7.39 about, so we'll go to a 7, and then a little bit more than 7 for the 7.39, and then up to 2, like that. Okay. And then we will connect those dots. And again, make sure that you kind of indicate that vertical asymptote there at the y-axis. All right. Questions on any of that? So we're going to mostly be focusing on log base 2, log, and natural log here. But the other log bases, log base 3, log base 4, all those other ones are similar kind of shapes. You'll notice that they don't look all that different, right? Just the sharpness of their turns. Okay. All right. We've already kind of talked about increasing, decreasing, horizontal asymptotes, vertical asymptotes, that kind of stuff. So we'll skip that part right there. I'm not going to have us worry about the behavior here. But let's take a look at the different kinds of transformations here. Okay? So we'll start here on the page 763. All right, so when graphing transformations of f of x equals log base b of x, where b is greater than 1, it helps to consider the effect of the transformations on the following features of the graph of f of x. So first of all, how is the vertical asymptote affected? Okay, so for example, a vertical asymptote is not going to be affected if you shift things up or down. The vertical asymptote will still stay the same place. But if you shift things left or right, the vertical asymptote will also shift left or right as well. All right. Next, also the point when x equals, oh, sorry, that's the horizontal, sorry, the vertical asymptote is when x is 0. So that's the vertical asymptote equation, sorry. And then our two reference points, which is 1, 0, okay, 1, 0, and also the point b, comma 1. Okay, so all our logarithmic graphs that we did, when you took the log of 1, you got 0, and when you took the log of the base, you got 1. Okay, and so that's what we're going to be looking at for our reference points. So 3 things that are going to kind of help us to use this: the vertical asymptote, and then reference points 1, 0, and then b1. Okay, and so we'll see how those things are affected. All right, but we can also kind of pick our points, you know, in a certain kind of way here. So let's look at letter A. Right here, you can see there's what we're looking at. So we want to identify the transformations of the graph, and then we're going to graph it. But they already did the graph for us, so we won't worry about that right now. We'll do that in a separate one. But so here's the graph. Okay. So for example, when we see this x minus 1, what do we know that kind of shift will be? Shift to the right 1, right? The number that's with the x, but it's the opposite of what you'd expect. So x minus 1, right 1. And what's that minus 2 on the outside going to do right here? Down 2. So right 1, down 2. And then what's this negative 2 in front going to do? Not a shrink. a stretch, but what's the negative going to do? It flips it. Yes, we have a flip and then a vertical stretch of 2. And so you can see all those things here. A vertical stretch by a factor of 2, reflection across the x-axis, and translation 1 unit to the right, 2 units down. Okay, and that of course then will affect the domain and range a little bit too. All right, and so here you can see how the graph is affected, right? So there's the transformed graph right here. Okay, but again, we'll focus on some of that here in just a second. Okay, so let's look at this next one here. Page 764. Okay, so page 764, x plus 2, how's it going to shift things?
2.
What's that?
Left 2.
Left 2, and the plus 4?
Up 4.
Up 4! You got it! What's the 2 going to do?
Wider.
Not wider, like vertical stretch by 2. 2 times as total. Okay? So there it is right there listed out too. Okay? And it looks like, I think that's the original, yeah. So we'll pick some points here. We'll graph this here on this little graph down here. Let me zoom out. Skosh. Okay. So now I want to be careful how I pick some x values here. So let me do this. So I'll pick some x values, and then we'll get the matching g of x values here. Okay. So since this is log base 10, I want to evaluate powers of 10, right? But if I pick x equals 10, what will I end up evaluating? The log of what? So if I say that x is 10 here for my table, when I go to plug 10 in, I'll be evaluating the log of 12. Do I want to evaluate the log of 12?
No.
I have no idea what power of 10 gives us 12, right? I want to match my base power to what's in here. So instead of picking 10, I need to pick a number that's 2 less than 10, so that when I add the 2, I'm going to get 10. So if I pick 8, like Greg suggested, 8 plus 2, 10. What's the log of 10? 1. But it's 1 times 2 plus 4. So we get 8, 6 is our point. 8, 6. Okay?
The next one will be 98.
Say it one more time.
The next x value will be 98 then.
98. Well, so right, yeah. If we pick the next one to be 98, then plus 2, that'll give us 100. Log of 100 will be 2 times 2, but 98 of course doesn't fit on our graph. So we probably don't want to go with an x value of 98. So let's think of some other x values we can pick. What about
110.
yeah, or how about this? What about negative 2? What's negative 2 plus 2?
I'll give you 0.
Oh right, 10, that's our vertical asymptote. I'm sorry. I'm thinking the wrong thing. Sorry. Oh, what about negative 1? My apologies there. Negative 1.
That'll be 0.
Negative 1 plus 2 is 1 log base 10 of 1. Or in other words, 10 to what power gives us 1?
2.
It'll be 0. 10 to the 0 gives us 1, so it'll be 0. Times 2 is 0 plus 4 gives me 4. So negative 1, 4. Okay, let's get some other points. I think I want to do, so we did 8, we did negative 1 plus 2, which is 1. Actually, that's enough points. We only need 2 points. Never mind, we only need 2 points. That's right. Okay. So again, since we shifted left 2, our vertical asymptote is going to be shifted left 2 from the y-axis. It'll go left 2, so there's our vertical asymptote right there, which is why I shouldn't have picked negative 2 because it didn't work. And then we'll graph the other point. So negative 1, 4, 1, 2, 3, 4, there's that point. Negative 1, 4, and also 8, 6. So 8, 1, 2, 3, 4, 5, 6, there's that point. Okay, and so just from those 2 points, you can kind of like get an idea about the shape of the graph here. Something like that. Okay. What is our domain here? All x values that are greater than what?
Negative 2.
Right, the farthest left we go here is negative 2, so it's x values greater than negative 2. And then what about our range? Negative infinity, less than y, less than, what's the highest y value looks like we're going to get to here? Positive infinity. Yeah, we're going to go up to positive infinity. Okay, let's try another one. Let's try another one here, make sure we're okay on that. And then I think... Yes, question. Yes, go ahead. Yeah, okay. Oops. There we go. Okay. So here we're going to do the same kind of thing. We're going to identify our transformations, and then we're going to graph it and applying those transformations. All right, so let me call on some folks here. Okay, so AJ, your number's up here. All right, I'll just have you do one of these things. All right, so that plus 2 on the end, how's that going to transform our graph? That's going to shift it which direction?
To the right.
Close. It's not right or left.
Oh, up and down.
Yeah.
So up.
Up 2, right? So we're going to go up 2. And then what about the x minus 1 there, AJ? I'm going to have you do that one. Sorry, the x plus 1.
The right one.
It's the opposite, so left one.
There's one word that I know it's the opposite.
Right. It's the one with the x. The one with the x is the opposite of what you'd expect. And then the one on the outside, that's the up or down. That's what you would expect. It's like, so the one with the x is the opposite of what you'd expect, and one that's outside, that's what you would expect, up or down there. So that's the left, right that are opposites. All right, cool. We have one other transformation, though. Let's go to, what's that?
1/2.
The 1/2. So that's going to shrink it by a scale factor of 1/2. So also shrink by a factor of 1/2. Okay, so those are our 3 transformations. We had to list those. But now we're going to make a table. Okay, now I need to pick x values that when I add 1, because you see I got to take my x value, add 1, then take the log base 2. So I got to pick some x values so that when I add 1, it'll be a power of 2. So let's go to Stephanie. So what's an x value that when I add 1 to it, it'll be a power of 2? Give me a power of 2. 4. I need to add 1 to get 4. So what's the number I add 1 to get 4?
3, 5.
What's that? 5 plus 1 is 4?
3.
We want to use the 3. You went the other direction. Not add 1 to it. We want to start with 3. So let me show you why. We start with 3. Plug the 3 in here. 3 plus 1, 4, log base 2 of the 4 that's in here. You see what I'm saying? What is log base 2 of 4? 2. Times 1/2. What's half of 2? 1. Oh my gosh, you're on a roll. Call you butter. You're on a roll. Plus 2 is 3. Okay? Feel free to use that, Carlos, later in life. Maybe when you're a dad, because that's more what appropriate for what a dad would say, I feel like. Okay? Yeah, you never heard that one before? Yeah. Well, see, Carlos doesn't know. He's leaving too soon. I'm just breaking out the gold material right now.
I just can't believe you just did that right now.
Oh, well, believe it, Carlos. Believe it. I'm pulling out all the stops today. All right. Let's try another one. So we did 3. Let's see here. How about 1? 1 plus 1 will give us 2. So log base 2 of 2, 1, times 1/2 is 1/2. 1/2 plus 2 is 2.5. Okay. Let's see here. I think we might be able to fit 8 on it, I think. Yeah, so if I do 7, 7 plus 1 is 8. Log base 2 of 8 is 3. 3 times 1/2 is 3/2. 2 plus 3/2 is 7/2, or 3.5. Yeah, that works. Okay, so now I've got 3 points here. Really, we only need 2 points, but 3 points is great. Since AJ told us that we shifted left 1, our vertical asymptote that was on the y-axis will shift left 1, and now it's at -1. So we'll graph that vertical asymptote there. And we'll plot these points. So 3, 3, 1, 2.5, so 2.5. Okay. And then 7, 3.5. 1, 2, 3.5. I'm missing another one that was pretty easy, actually. If we did log of 0 here, 0 plus 1 is 1. Log base 2 of 1 is 0. So that actually would have been an easy one too, right? You can take the log of 1 pretty easily. So again, we plug in 0, plus 1 gives us 1. Log base 2 of 1 is 0, times 1/2 is 0, plus 2 is 2. So we get the point 0, 2. So there's our graph there. Okay? Oops, I'm off the screen a little bit. Let me zoom it out. There we go. So you just want to be careful about how you pick your points. Now, believe it or not, you can actually graph this in your graphing calculator without too much effort. All right, let me show you how we can type something like this into our graphing calculator. Okay, because some of you maybe will want to be able to graph this without having to, like do the mental math. You just want to be able to use your graphing calculator to do it, which is fine. Okay, to graph this, we're going to do the 0.5, and then we have to type in log base 2 of x plus 1. For those of you that have the nicer, newer calculators, if you press the math button and scroll all the way down to that log base, you can type in log base 2 of the x plus 1, like that, and then plus 2. Okay. And then you can graph it. Huh. Interesting. Mine doesn't graph the whole. Mine doesn't graph down there. If I trace though, it should.
But if it's supposed to be negative, wouldn't it?
Yeah, but.
If you had -2 in there, then it would be taking a negative number.
But the idea is, since we're approaching that vertical asymptote, it should go down to negative infinity. It should because of the shift there. But let me see here if I can make this better. Let me try zooming. I'm going to change mine. Let's do this. -2 to 2. Let me try it that way. Okay, now it's showing you a little bit below the x-axis there. But I guess the calculator just kind of cuts it off, which is unfortunate because that will mislead you potentially. Wow, it's still not doing it. Let me try negative 1.5 to 0.5. Oh, negative 0.5. Yeah, it's still barely showing how far it goes down there. So it's not showing the whole graph, which is very interesting. But at least that's how you can graph that if you wanted to graph it. Okay, but it's not showing the whole thing. Now, what if you don't have these nice calculators that allow you to do this log base like I'm doing here? Well, you can still do it using change of base. Remember from change of base formula that if you have something like log base 2 of 5, we'll say, that's the same thing as saying log of 5 divided by log of 2. Or it's the same thing as saying the natural log of 5 over the natural log of 2. Okay? These three things are all equal.
Can you just do 2 to the x power 5, and then do 5 another step?
Yeah, and solve it that way, right. That's absolutely true. But again, and you use your calculator for that, I guess, too. But then for something like this, we can use change of base as well. So we can make it 1/2, so the log base 2 of x plus 1 plus 2 like that. We can rewrite this logarithm as something like 1/2 log of x plus 1 over log of 2, like that, and then plus 2 on the outside. You see how I changed that logarithm? Log of the x plus 1 over the log of the 2, and then the plus 2 still on the outside. Or you could use natural log, 1/2 natural log of x plus 1 over the natural log of 2, and again plus 2. Either way, you get the same graph, and I'll show it to you here. 0.5 log of x plus 1 divided by log, don't forget to close the parenthesis for the logarithm, 2, and then plus 2. I graph that one, and it's the same graph as before. Okay, but again, there's our vertical asymptote right there, and it should keep going down, but the calculator can't graph that for some reason there. I think it's too sharp of a term for the calculator. Okay, that's how you can use your graphing calculator to graph that. All right, so I think we can skip this stuff right here. I don't think we need to worry about this. Population of foxes, tail gives data, population of foxes. Yeah, we don't need to worry about that. Okay, yeah, okay, so we can actually skip to the assignment here, okay? So, yes, here we go. All right, so I'm going to have you guys start, I think, on page 771. Yep. We'll start on page 771. And I'll have you guys do numbers 3, which has parts A through F there. That's just describing the transformations. Just describe the transformations. Don't worry about like describing the domain or anything like that. Just describe the transformations for now. And then also I would like you to try number 4, 6, and 7. Those are just graphs. And then let's see here. Yeah, I guess I'll hold off on that. Okay. We'll go from there. We'll just do that. Not very much, okay? Should be pretty quick. We'll give you those 4. But 3 has multiple parts, so just don't forget. You're going to list all the transformations there. 4, 6, and 7. And of course, you seniors